data representation in our computer and file structures. Actually, I wanted to focus more on the data representation part. About the file structure, you will have practice hour, and also, some of you have also know that, know about how our data is organized and stored in our computers and in other information systems. First of all, do you have any question concerning our previous lecture and our practice and our midterm and final test? Just raise your hand if you have any question concerning our lectures. How about the practice? Is that difficult? Is that too easy? You can handle it. Sometimes it's difficult. Sometimes it's already. For example, any comments and questions, please? No? Okay. We'll continue our lecture today on data representation and file structure. And of course, informatics and computers are now so popular. In the past, only people in the ICT field have chance to work with computer. But nowadays, the computers are everywhere, including in our television set, in our mobile phones. Almost, I think that 99.9% of the students now are using a smartphone. This means that inside that smartphone we do have a computer, including CPU, RAM memory, storage devices, and so on. And all smart computers now are able to connect to the internet, not only using the telecommunications channels. Let me talk again about the DI-KW pyramid. As all you know that, everything stored in our computers sequence of 0 and 1s. It means that almost all our computer nowadays store the informations doing information processing, calculations, transferring, storing the data, our informations using 0 and 1's character only. And 0 and 1 is just the raw data, the sequence of 0 and 1's is just only the data. And without knowing about the structure or rules or metadata for that files, for that storage unit on the hard disk, we could not know what it is. For example, with the 10 characters like this one, 09, 122, 009. Some people know that, and to guess this password, it's just a random number. It's just a date in a day, for example. With a more structured or the meaning or metadata of that data, we know exactly what it is. For example, if we are given the structure of the 8 characters like this. The first one is to the date, second one is for the month, and the last 4 digits are for the year. So we exactly, this is December 9, 2009, for example. So data and metadata about the structure, about the meaning, it becomes information. Data becomes information. And yeah, talking about the computer world, because before having the computer to process the data, process the information, people do information processing. It means that remembering the information by writing knowledge, writing documents, writing stories, for example, on the paper. For storing, that's for information storing. People could send the email. It means that transferring information from this people to another people. People do, seeing taking the pictures, viewing the videos, for example, without using computers. So nowadays people wanted to use computer to process the data, process the information. So we need a way to convert our informations, into the digital world, and usually the devices that capture or transferring the data for the information from the real world into the computer world is usually called the analog to digital conversions. And from the information we collected from outside environment are transferred to the computer world and stored in just 0 and 1 signals. That's the common way, and this is the most common way to manage or to process information, to manage the information by using computers. I wanted to use this slide again. Actually, in many of my lectures, I use this slide to talk about many aspects of these applications. This picture, the first thing I wanted to show in this picture is that what we saw here, what we see here is entire pictures of a warning board about the page is closed because recently the server shark attack, for example. That's what we see in a daily life in a real environment. But the computer, what the computer process is just a series of number like this one. And of course, the computer know that, the meaning or the arrangement rule of those number. For example, every pixel, 3 digits, for example, 3 numbers. We form the color, we define the color appearance, for example, like this one. And the way of the way the computer process information is quite different from the way that our human eyes is process the information. Our human eyes and the brain, the signal processing in our brain, of course, they are different. And now, different, for example. So in order to process the information in a correct way, in an appropriate way, we need to know the basic principle, basic knowledge about the data, about the information, and processing information by using computer. And of course, if you use your mobile phone, you use the computer to process the information every day, and you found that there's nothing too difficult for you, for example, to taking the pictures, for writing the document, for making the slide, for example, for do some calculation using computers. You found that there's nothing too difficult. But the problem is that when the requirement of your study, when the requirement of your future work, it requires, for example, a professional level of paper of information processing. So at that moment, in that case, you need to know the basic principle of data, basic principle of information, and the fundamental knowledge about the computer. And when something happened, your computer could not start, for example, you process the data, but something went wrong. Your model processing data produce no good result. When writing your documents, you send to your professor, and your professor could not read your documents. When you transfer the data to your classmate, for example, for further data analysis, your classmate or your supervisor could not see your data, could not read your data. So in such a case, you need the basic knowledge and also a lot of experience. So you could figure out the reason why you could see your data, you could see your information, but other people could not. In such a case, in such situations, we need not only the skill to use the software. We need not only to read the manual of using a mobile phone, of using a computer to figure out why something went wrong and why your work couldn't go smoothly. So that's why in this course we wanted to provide you basic information about some very fundamental concept and fundamental and basic skill for you just to know that there's something there. And if you wanted to study into more detail or something similar happen, you know the way or you know the direction to fix it. Now let's take an example of a text file. This is the most basic data sources and the most basic form of information that we are dealing with the text files every day. But even the text files, there are many things you should pay attention and you you need to know. Let me take an example. Could you see my screen clearly?
Yes, we can.
Yes, Professor.
Yes. Thank you.
Yes.
Thank you. Thank you very much. Yeah, here I'm making a document, and my document has only 4 characters. Yes. 4 characters. And for example, just a very basic things. I wanted to show you the demonstrations. The normal font size of the notepad is 12, 12 or 11. Yeah, okay, it's just 12. And this normal particular, you could see that you could still see the content of my documents, USH. But in order to improve the visuality or the for better view for your better view of my screen, so I changed the same font with a larger font size with a bold font styles, for example. Just a very little thing like this, but it have or it gives the audience a much better view, for example. So please care about or please pay attention with your audience when you present something for example, for supervisor, present something with your classmate, trying to know the basic thing and trying to care about your audience. Yeah, this is what, the first or the basic principle of communication. Yeah, try to have the audience to see or to get the message of the speakers. Yeah, now my document has only 4 characters. And in the Notepad application pre-installed in every Windows operating system version, I save the document with 4 characters into I delete this. I save the document with the name USTH, okay, for simple, for remembering. Yes, and there are several file names, file type, TXT, yeah, stands for text files. And the encoding, there are several encoding scheme here. The first one is NC, the second one is UTF-16, LB, 16B, and UTF-8. Now, I select the ANSI first. The encoding scheme is using the ANSI encoding scheme, and I save to the this folder. I save it because my document has 6 characters, so my size, my file size, the name USTH here, the extension is text files. The file size is 4 bytes. Okay, I understand that. Yes, I have just saved, create a new document. And my document has 4 characters USH, and my document requires 4 bytes to store the content of my text file. 4 characters, it requires 4 bytes. Now, with the same document, I save the document in another scheme, encoding scheme, UTF-60, for example, the second option. Now, USTH with the UTF-60, just for short. Yes, the same content I save to another file name using another scheme. Now, some people guess how many bytes are required for storing my document of 4 characters USDH Yeah. If I save my document with the encoding scheme is UTF-16. Please raise your hand if you have the answer, please. Now you guess. Of course, yeah, you have, yes, okay. Đức, please.
So knowing that normally one letter should be 1 byte in the language of computers, it should be about 4 bytes. But knowing that you also encoded it, it might be more than 4 bytes. But it's definitely less than 1 kilobyte.
Less than 1 kilobyte, of course, we know that because it's just only 4 characters. It has just only 4 characters. But how exactly the number of bytes required for storing this text document?
Since it's encoded, maybe it should be around 10 bytes, maybe?
About 10 bytes? Yes,
maybe.
Exactly. I'm asking about the exact number because we need to know the reason why it is a 10 byte, or it is 8 byte, or it is 5 byte. Okay, some people said that, yeah, it requires 5 byte. Okay, so let's discover it. Yeah, look, is right. It requires 10 byte. Okay, now it means that with the same content USTH, when we the AMC, it requires 4 bytes. Is this because, yeah, we if we know what really or actually really happened, for example, we not only can guess or calculate exactly the number, but more importantly, yeah, we could explain or we could know the reason. For example, in the future, you may conduct some experiment and it produce some result, and you report the result to your supervisor. And the supervisor, usually in my case, I do not ask about the number. I would ask about why it is. For example, you said that, okay, my experimental result is not so as good as reported by other people. Or some people report me about that, okay, the accuracy of my model is higher than other models. I don't care about how good it is or how significant the number is. But the first question I ask my student is that, yeah, why? Why something went wrong, or why it is better than the other? So understanding means not only about guessing exactly the number, but we need to know the reason why it happens. Now, the answer in 4 byte, I think that 4 characters because it has 4 characters and each character for 1 byte. For example, 1 byte for 1 character. So it costs me 4 bytes. Yeah, for the ANSI case. Now, for the UTF 16. Now, yeah, you could guess that, yeah, it has 4 bytes. But more importantly, you should know the reason why it costs 10 bytes. For example, in this case, I know that I have 4 characters and it should be multiple or plus something here in order to have 10 bytes. If we fill up the 3 dots here, we understand the problem. Now, okay, ANSI used to mean that the standard for character coding, and it uses 1 byte for 1 characters. And we have 4 characters, so we need 4 bytes. For UTF-16, okay, 16, I could guess, yeah, 16 is mean that 16 bits. 16 means 16 bits, and 8 bits we form 1 byte. It means that 4 characters multiplied by 2 bytes per characters plus something here, and we will have 10 bytes. Okay, I guess 4 characters, each character requires 2 bytes, and must be some 2 bytes here. Okay, we got 10 bytes. Now, let's verify it. Now, I saw expect, yes, here is my first document encoded in ANSI. I see the every characters. The first character is 55. That's the code for the character U. The second value is 53. Is encoding or code of the character S. The next 54, 48 is for character T, and exactly 4 bytes for 4 characters. Now, for the next bytes, UTF, 16. We also view the content and not in Unicode, but in hexagonal. Now we could see the content of this file. The first, because we know in advance the content of our documents. U, S, T, H. The U has 55. Okay, it starts from 55. 55, 00, 53, 00, 54, 48, for example. Okay, I know that the UTF for 16 use 2 bytes for storing 1 character. So the first character is the U require will be stored in the third and the fourth byte 55 and 00. Yeah, I guess that. Okay, 4 characters, 10 bytes, and another 2 bytes that has value FF and FE. So we got 2 bytes here. It means that for the UTF-16, the content of the documents, in this case, is a text format. Require 2 bytes, use 2 bytes to store the information about 1 character. And the first 2 bytes is FF and FE, and I don't know what it is. Yes. So we found 2 bytes. We found 2 bytes here. That's the problem. Okay, I wanted to discover more. That's for English characters. Now, my document is not in English characters. My documents contain the character set in other format. Yes, now, this time my document has the 2 words, Viet, Pháp, means Vietnam and France. I saved also, okay, I wanted my file is as small as possible because it saves the space or saves the bandwidth when I transfer my documents to another people, for other people. Yeah, because it's smaller. Yeah, I just only. Yeah, I think that ANSI is preferable because it contains all the information. Besides, it requires one character, one byte for one character. So it saves my disk space and it saves the bandwidth when I transfer the documents, for example. So I decided that, okay, I write my document in VP, for example, for VFA character using the encoding scheme because I wanted my files, yeah, as small as possible. Yes. Okay. So the program, yeah, inform us, warning us something when you do something, when something wrong or it's not appropriate. Usually, program will give us some warning, and in this warning, the program, the Notepad program, say that this file contains character in Unicode format, which will be lost if you save this file as ANSI encode text file. To keep the Unicode information, click cancel below and then select one of the Unicode option. Okay, so it warning. Okay, I insist the program to write. Okay, VP in ANSI. For example, I try. Yeah, VP in ANSI. No. In ANSI. Okay, not this the ANSI. Next, previously I used UTF-8. UTF-8. So I try to rewrite it and rename the UTF-8. The program automatically recommend me about VP UTF-8. And when I save the text file, my text file into the UTF-8 format, okay, the program does not give me any warning. But I think that is not good. I save with the ANSI encoding scheme. Okay, program warning me, replace, yes. I insist. Wow, it changed, my content changed. Yes, some character change, some character does not change, like this one. Now, I inspect again the two files I have made here. The VP and C characters files, yeah, has 9 bytes, and the VP UTF-8 has 12 bytes. Wow, wow! I could not see it, but when I type, I got the document. Yeah, the content changed. Now, someone explain me why, yeah, something happened and why something went wrong with my documents. Why? Yeah, we know exactly yeah, the difference between the English documents USDF and this one. This the ANSI encoding. This be USD8 coding. This file has UTF-8 requires 12 bytes and ANSI 9 characters because I know exactly 1, 2, 3, 4 with the space is 5, 6, 7, 8, 9. 9 characters requires 9 bytes. Okay, I know that. But why UTF-8 requires 12 bytes? Now, for the next character, next document is with the Việt Pháp characters ANSI cost me 9 bytes. With the UTF-8, it requires 12 bytes. Okay, I know that 9 characters. Each character requires 1 byte, 9 bytes. Now, I need to know once again 8 characters, 9 characters, 9 characters. Multiply by plus equal 12. Now, some people tell me why. Some people please tell me why it requires 12 bytes. Yes, Đinh Huy Thái Sơn, please.
Okay, so for UTF-8, I think each character will require 1 byte. So 9 character multiply 1, I mean 9 bytes, and plus more 3 bytes.
Or 3 bytes. 3 bytes. Okay. So what is the 3 bytes? Yeah, we have 2 bytes here. Okay. What is the number 3 here? Why? It's 3, not 2. Do you know the answer?
Sorry, I didn't know yet.
Okay.
But,
Yes, I can.
but
Yeah.
for the
Okay. Thank you, Thái Sơn, because that's what we are learning now. We are discovering now. Thank you. Nguyễn Phan Gia Bảo, please. Okay. Sơn said that. Yeah, Sơn said that because we have this A plus the Vietnamese accent side, right? Okay, thank you very much. Yes, now we inspect the files again. We write the whole content in hexagonal. Now the first character V now is 56. It means that the first byte in my documents. The character I has the ANSI encoding is 69 in hexagonal and something like that. 1 byte for 1 characters. Okay, it's easy to understand. Now with the that's it. This is for that the ANSI. Now for the UTF-8, yes, option we saw the binary. Okay, the same thing. This is okay. Now I'm trying to save the same document for in the another scheme UTF scheme. I have to make one more document to save one more files for the illustration purpose, for our learning purpose. UTF-16. Yeah, my content is still okay. No. Now for 16, it costs more 20 bytes for the same documents, and we expect this UTF-16. Okay, we still see the content here. Because UTF-16, it requires 2 bytes for, it uses 2 bytes for writing, for storing the information about 1 characters. So yeah, it costs, because we have 9 characters. Okay, once again, now we have UTF-16. It requires us 20 bytes. Now 9 characters multiplied by 2 characters plus XXX 20 characters. 9 characters multiplied by 2, it means that 9 characters cost 18 bytes. 18 bytes, it means that the remaining is, it would be 2 bytes. Yeah, we could see that for the UTF encoding scheme, we need first 2 bytes for something. Now we inspect the first 2 characters are FE, FF, and FE for the VF5 documents. We inspect again the USTH, also option echelon. We could see that yes, both USTS and VF5 documents contains the same first 2 characters, FF and FE, FF and FE. Yes, we found that. And in fact, every text document, text files, yeah, if you write or if you save the files using the UTF-16 encoding scheme, the first 2 characters are always FF, FE, and actually this is defined by standard. For UTF-16 to both, yeah, we save the document in UTF-16 LE. We have the first 2 characters FF and FE at the beginning of the files. This is used by standards, by some standards. And if for the documents in the ANSI, we have just only the content of the text files. But yeah, for other encoding scheme, they have some representation or the mark for that files. So that's the reason. And why? The reason why we have in UTF-8 12 bytes, because this is a +1, +1, +2. 2 here, yeah, are not the same. That's the rules. That's the signal that recognizable by the components. It means that when you open a text file, when you open a text file, if the first two characters with the signal FF and FE, you know that that text file is encoded by 2 bytes, and every character will be represented by 2 bytes in the content of that file. So people have defined different standard for storing our information. Why do we need such kind of standard? For example, in the Windows file system, we have the name of a file, the extension of the files. The name is for the user or created by some people. But the extension, of course, we could change the name of the files, but usually the TXT stands for text files. PPTEX standing for PowerPoint files, Microsoft PowerPoint files. The .x or .doc is for document files created by Microsoft Word, for example. The zip files, this is some standard for or some format for compressed files. The bitmap, BMP, stands for bitmap. The JPG stand for JPEG. PNG for one format of documents, for example. And for the PDF files, for example, every PDF files has this signature. You could see the percentage mark, and next is a PDF, and the next one is the version of the PDF files, for example. And inside, there are so many information and also the content of the documents. We could open this PDF files here. We got the document, but this is what we see. And the actual files, the actual content is hexagonal. Yes, the first characters or the first bytes in a PDF file. For every PDF files, you could see the signal percent PDF with the version of the PDF file. Now, my question: why people need for just only the text files? Only the same text files. We have different way of we have different standards for storing our information. We have different way of storing our information, and we have different signals for storing our information. Or actually, it's our data. Yes. Tyson.
Sorry, I haven't lowered my hand
for
last time.
Thank you very much. That's because when you send you create the document and you save the document in the unzip from file format. You save it in the UTF-8. You save your document in to the UTF-16 encoding scheme. You know about that, but the problem is that other people may not know about that. So you need, besides the data you send to your friends, you send to your boss, you send your files, or you ask to send it to another computer system using different use another operating system. You wanted other program also could other program could also display your content. So the first thing first, not only you send them not only the data, the content of your document, but also the format or the metadata about your information, and also the same thing for different computer system. So that's why you know that in some application, some software, it is available for Windows, but not it could not run on Mac OS, or it could not run in the English, or for some documents, for some pictures, you could not view the pictures in another operating system. So please, so that's the normal. So that's why people require standards for storing the data, and different standard, different encoding scheme could cause you some trouble in practice. For example, with the same software, yes, for UTF-16, I just put the quick view, for example, quick view, the total commander using the internal viewer provide me exactly the content of my documents. But here, with the ANSI encoding scheme, because although it requires only 9 characters, but the total commander inside internal viewer could not display correctly the content of my files. And sometimes, and actually in the daily life, sometimes you could say that you could see some very strange characters appear on your television screen. Sometimes it convert, it displays some Chinese character here, because the program misunderstand about the structure of the files you are given here. So because I also experienced that, sometimes my television set display does not display correctly the button and the information display on my television screen. It's not correct, and I could not read it, just Chinese character like this. So it's not, when you know about the format or the data representation or the information, or the difference between the data and the information, that if we are given no clear or inexact definition of the structure of the data, or we are given wrongly the meta information about our data, some program could work incorrectly in this case. So that's why yes, UTF-8, for example, sometimes it does not display correctly the content. Also, the content is here, but other program may not display the content correctly. For English character, yes, in this case, also the same, something like that. So you learn about the data representation in your data, in your computer. So you should, you know that without the metadata, or without the structure of your data, it could not become information. It could be an information, but it is incorrect information. Okay, for example, there's also confusing here if we don't have, for example, it could be September 12th, 2009. So according to some rules or according to some conventionals. Yeah. So in short, by storing in our information in our computers, yeah, the data is just a sequence of 0 and 1. And in order to understand or to process correctly you should provide not just
Professor, you're lagging. We can understand what you're saying.
the example of a text files to. Okay, thank you very much. And I propose that we take 10 minutes break. Now it's according to my clock, it's 57, and then we come back at 2:05. So please, could you hear my voice and see my screen?
Yes, we can.
Yes, teacher.
We continue. And I take another example to talk about data representation. This picture I took from USDH homepage last year, and I prepared the content based on this picture. So this year I continue to use this picture. I downloaded this picture from USDH homepage, and I saved it into two different bitmap files. The first bitmap files I use 24 bits, and the second files, I use 8-bit encoding scheme. On the screen, the quality of the two pictures, of course, is different. The quality is different. And also with the 8-bit scheme, the file size of the bitmap image is more than 2.6, nearly for 2.6 megabytes. And of course, for the 24 bits, it means that it requires it uses 3 bytes for storing the information. 1 byte for red, another byte for green, and another byte, the third byte for blue values. And it costs nearly 8 megabytes of data to store for storing the pictures. And here, this is the inside of two files, USTH8.bitmap and USTH24.bitmap. Here, we could verify it. USTH, maybe extends citizen check bitmap. So this one, USTH 8 and USTH 24, you could see the difference. And for USTH 8, it costs 2.6 megabytes. This 8 megabytes. Now, I view the two files and I compare the content of the two files. And the first 1, 2, 3, 4, 5, 6, 7. The first 8 bytes of the USDH8 has the value here. Has such value here. 42, 40, 76 to 7, something like here. And the red color means that the total commander highlights the differences between two files. We could see that, yeah, also with like the text files saving in the UTF-16 file format. It has some 2 bytes. Yeah, there are 2 bytes. It is called the signature or mark bytes for the bitmap files. You open every bitmap files. You see the 42, 40 values for every bitmap files. And the next 4 bytes are different. And because the bitmap is a common format for storing the common extension of the bitmap image files, and the structure or the metadata of these files were public for every people. And this metadata or this structure of the files will be used by computer programs to read the information and to display the bitmap file in a correct way. For example, with the total commanders, for example, we select the bitmap files and we could see the properties, different property, and also the detail here. For example, the total commander internal viewer could read the content of the bitmap file, and they got basic information, the metadata of the pictures. For example, the dimension is 2000 by 1348, and the bit depth is 24. The size is 7.71 megabytes, and some others. Actually, the total commander program read the metadata in the bitmap file header, and in the bitmap file header, yeah, we could see that the first 2 bytes are for the signatures. The signature here in this case is the 2 bytes with the value 42 and 40 in hexagonal numbering system. And the next 4 bytes are used for storing the file size here. Actually, yeah, we could verify, or we could get the size of a file in different way, but for the bitmap files, the file size, also the information about the file size is also stored in the header of the bitmap files. Next 4 bytes are reserved for future use. The next 4 bytes is the file offset to pixel arrays. It means that, yeah, from this one, from the beginning of the files, the raw data of the image is 1 byte or 3 bytes. We will store from this position to the end of the file. And the next information is about the deep header. Deep means device independent bitmap. Device independent, that's information for display or viewing the picture in any devices with the image head, because the data for storing every pixel a sequence, just only the sequence of numbers. So we need to know the image width and the image height, yeah, in order to display the image correctly. Bits per pixels, for example, for black and white bitmap files, the bit per pixels could be 1 bit per pixel. For example, in this case, it's 24 bits per pixel. Compaction or not, image size is pixel, for example, per meter. It stores the information about, for example, resolution of the image in, for example, dot per inch, and etc. Many things. Yeah, and after all the metadata, the space for metadata, the raw data begins. The image data will start from this location. That's the structure of a bitmap files. And also we have the structure of a PDF files, a movie files, MP3 files for storing the music, the zip or the task files for compressing data, and many other things, many other types of information. Now, let's inspect more into more detail about the number, about the informations. The bitmap file header consists of 2 bytes. Yeah, this is a standard, and every computer program and library, yeah, should use this information for correctly processing the information stored in these files. The first 2 bytes are for identifying the bitmap files, and it has the signature of 40, 2 and 4D in hexagonal. The next 4 file is for the size of the bitmap file. We know that, yeah, when we save the picture in using 8-bit 8-bit format, the size of the file is 2.6 megabytes. When 24 bits are used, the size of the picture is nearly 8 bytes, 8 megabytes, 7.7. We know that the first 2 bytes are for signature, and the next 4 bytes are for the file size. Now, let's check it again. The size of the first file is 2.6, but what we see is 4.6 in decimal, and this information is stored in the 4 bytes of the bitmap file header. Now let's check again whether or not those 2 bytes, 4 bytes are for the file size or not. We check if, yeah, whether or not so 2 numbers are the same. So let's check it to verify that if we understand the problem correct or not. We understand the problem correctly or not. Okay, so let's start. You could see that, for example, in this case, yeah, in this case, when I created the text file here, because yesterday some people asked me about why the order of the number is written in the hard disk in the inverse order. So I would like to take this. Files as an example. Our character as U, the first character in our document, U, has the code of 55 in hexagonal. And the character use 2 bytes for encoding. So the first, the number should be 0055, but the order of the byte written in our hard disk is in inverse order. It means that 0055 for the character U. Yeah, that's the root, the order used in our file system. Now let's take it. We know that in decimal, in hexagonal, in binary writing system, we know the rules. For example, in decimal writing numbering system, we have 10 digits, 0, 1 to 9. But for hexagonal use 16 digits to encode the number 0, 1, 2, 10, 9, A for 10, B for 11, C and E and F. So that's why sometimes you saw sometimes when you view your content of the hard disk, you saw, for example, FF for 255. And the rule of writing is rather simple. For example, and also for the binary numbering system 0 and 1, and or you could remember in our first lecture about the history of computing, you saw the movie or the video clip, the animation, more exactly the animation about our mechanical calculator. When you rotate the mechanical computer, when you sum up 3 with 7, the result is 10, but only character 0 was displayed on that on the windows of that mechanical computer. Yeah, something here. For example, the rule is simple. If we write a number in decimal numbering system 26,97079 means that this number equal to 8, the first number, multiplied by 10 power 0. The second number means 78, means 7, multiplied by 10 power 1, and so on. We know that's the rule, and this rule is common for every numbering system. Now use your pen and paper to verify that. So this number 26,97079, that is the size of the files, and this number is written in our hard disk. This number is the size of this file, and the number stored in our hard disk 00, 29, 27, 76, 00, 29 are the same. It means that they represented for the same number. It is the file size or size of this file. And also we check it again with another files. The picture written using 24-bit encoding. Now please use your pen and paper to do the calculation to verify that the two numbers are the same. The difference is that they are written in different numbering systems. Try to do the practice. I will give you 3 minutes to finish the verification whether or not two numbers are the same. Of course, obviously, yeah, you know, if you could verify that, you know that, okay, that number, uh, we saw the number and how it is stored in our hard disk, how it is saved in our hard disk. Now, all of us using your pen and paper, or of course, you could use calculator or some tools to verify that's two number. 3 minutes starting from now. Who finished the verification that those two numbers are the same? Okay, so we do it together. Yes. Okay, according to that, the above rules we have in hexagonal right numbering system is 6 plus 7 multiplied because it's hexagonal. 10 is, yeah, in decimal is 10, so in this case it is 16 power 1 plus 7 multiplied by 16 power 2 plus 2 multiplied by 16 power 3, and so on. Now, you could verify. Take the sum. Of course, if you use a calculator program in your mobile phone or in your computer, you just simply write down this number in decimal, and you switch the numbering system into the hexagonal or binary. You could get this number. Up to now, do you have any question about the numbering system? How data and metadata will store in our computer so that other programs, other computer system could understand correctly and could process correctly the data files.
Professor, I have a question.
Yes.
For hexagonal, when there are letters, what do we multiply? What operation do we do to calculate the size of the file?
The size of the power?
Like with hexagonal, when there are letters, like for example, the one hex 007B69F6, how do we calculate the size?
Yes, it's mean, for example, a positive, how to distinguish a positive and a negative number, right?
Not.
No, not really.
Because for hexagonal on the left side, we multiply by, for example, 7 times 16. And for the one in the right, when there are letters, what do we do to calculate? Like, how do we calculate when there are letters?
Yes, actually, yeah, we write here. Okay. We write it here. This actually in the decimal number, because we wanted to convert the hexagonal to verify it in the decimal number.
I'm asking for the example on the right side.
The example for the right side here?
No, yeah, the hexagonal 007. What do we do when there are letters? Like, how do we calculate?
Okay. I see. Yeah. For example, in this case, your question is that how to work with the letter, for example, F,
yes.
Right? Okay.
Yes.
Now, for the right number is also the 6 plus F. F in hexagonal is mean 15 in decimal. So we use 15 multiple this one because we wanted to convert a number in hexagonal to convert it to the decimal. So we use the decimal number to calculate it. For example, in this case, F is 15. This case power, something like that. And the next number is 9 multiplied by 16 power 2. Yes. Is that your question?
Okay. Yes. Thank you for your answer.
So you could verify that, yeah, two numbers are the same, and you understand why we saw this number by using our software, our operating system. But actually, this is actually store the numbers are exactly how it's stored in our computer, and so on for other metadata, other type of metadata. Next question, please. Could you verify it? So our two numbers are the same? Because you understand the principle. You don't know all the definitions. And now you should try to verify it by practicing through the calculation. Next question, please.
Yes, Professor. So I have finished the calculation. Is the same for hexagonal? The question that you asked.
Okay, thank
It's
you
the
very
same.
much.
It's the same.
Yes, thank you very much. And yeah, converting a number in hexagonal into decimal is in that way. Now, for your homework, try to convert a decimal number to a hexagonal number. And to predict or to guess, yeah, how the number in decimal is stored in the hard disk. So this, for your homework, you could do it later after our lecture here today. If you don't have any question more, we move to the next part. Yesterday, some student asked me about why it is in hexagonal. Very interesting question. Why it is in hexagonal, but not in another numbering system. So that question is interesting, and you could Google or to find the answer for that question. And I would like to move to the next. Actually, that is the content of my I have prepared in the next slide. The question is that why do we use the hexagonal numbering system? If you don't ask me, so I have to ask you, because we discover the knowledge together. Now, who has answer for the question? Why our data usually display, or our information, the data usually display in hexagonal number, not in the decimal number. But our daily life is mostly, we use the decimal numbering system for writing the document, for writing the report, for displaying the price of the goods, and many things. Most everything we use decimal number. The question is, why don't we use the numbering system, the same numbering system in computer world, but the hexagonal? Who has the answer? Who has the explanation, or who has some hint, some explanation about that question? Please raise your hand if you have any idea for this question. Yes, Đào Xuân Quý, please.
I think the reason why we're using the hexadecimal in computer, because it is easier to understand for computer, and also easier to understand for us. I think that.
Okay, we said that because the hexagonal is easy to understand both by computer and by the people. Thank you. Nguyễn Trần Hùng, please.
So I think instead of having both two decimal number and one decimal number in a system, we only have single decimal number in the system, so it would be easier for computer to process the information.
Yes. Yeah. It said that. Yeah. Actually, we use the both two numbering system, but for the convenience, for the convenience of using the two for the calculation and for the storing the data, we use both numbering system in a computer system. Next, please. Yes, you answer. Yeah. the main reason why in the computer system we use the hexagonal, because first of all, it's rather convenient for us and also computer. For example, why people don't use the binary to display the number? Yes, in decimal number, we are very familiar with the decimal numbering system. For hexagonal, it's not so difficult for us to read the content. And more importantly, as like I said, everything stored in our computer now are just 0 and 1. Of course, in the future, we may have the quantum computer, so the value stored in that computer, in quantum computer, could not be may not be the 0 and 1 anymore. But nowadays, in a computer world, everything, yeah, we store the data like this one. You could see that, you could verify that, and we send the data from this machine to another machine. Every raw data is in 0 and 1. But if we just use 0 and 1, this number could be very long, and actually it's, yeah, very, very long, because that 4 bytes, and each byte has 8 bits. It meant that if we write this number in 0 and 1 only, so this string we have length of 32 numbers, 0 and 1, and it's difficult to see or to distinguish or to calculate or to display it on the screen. For example, it's difficult to remember, and people use 8 bits together to form a byte, and 1 byte consists of 256 different values for 1 byte. Yeah, so that's why, yeah, we use the 256 values will be displayed by using 2 characters, FF, from 00 to FF, and FF still easy to remember, much more than 11111001, for example. So that's the reason. Here, if we store the same number, and the string should be very, very, very lengthy, and of course it's difficult to remember. Now, next question: why binary? Binary because why binary? Binary. We know that everything is stored in 0 and 1. Now we ask again, why binary? Why do we have to discretize or convert the real signal in infinite number of strands, of variable strand values, into a concrete number or discrete number? This means that we can count the number of values. And now we ask a deeper question: why all the computer currently, most all of our computer now have to use the binary numbering system? Who has any idea? Yes, Bùi Huy, please.
The CPU is made by transistor, which is used turn on and off.
Yes, he says that, yeah, because the 0 and 1 signal will be processed by transistor, and the transistor takes the signal just 0. It means that we have some power there, and on, that's for on. Off is then that there's no electric signal or the power on the input, for example. So that's the idea of who else. Yeah, actually, yeah, that's the way. Yeah, I like that way, because actually we use 0, 1, 1 because he has answered his question is exactly the answer in my next slide, and I prefer that way of discussion. Actually, we could do the calculation in any numbering system, but the problem, we could do calculation in decimal. 7 plus 3 is 10, 2 plus 1 is 3, for example. We could also do the calculation in the hexagonal numbering system. For example, 10 plus 1 is A, 10 plus 2 is B, for example. But we could only design currently. We could only design the operator using only two values of input, 0 and 1. For example, with the binary addition, we could do the addition in any numbering system. For example, for binary numbering system, we perform the following operator. For example, with the input of 0 and 1, 0 plus 1 is 1. 1 plus 1 is 10. 10, because we have only using one character to store 1, and if we keep the unit, here is 0, and we remember the 1 of the 10th is for the next column. We have 1 plus 0 is 1 plus with 1 carrier value. 1 carrier, it becomes 10 again. So we write the value here, and we remember, or we carry the number 1 for the next column. 1 plus 1 is 10. 10 plus 1 is 11 in binary. We write down the 1 here, and we remember, or we carry out the number 1 for the next column, and so on. 0, 0 is 0 with the value of carrier 1, we have 1, and so on. The rule or the principle for adding two numbers in the decimal in hexagonal are the same. But the question is, why don't we use hexagon? Why don't we use the decimal? But we have to use the binary numbering system in our computer currently. That's because exactly the answer of our students. We wanted to design an electrical calculator. In the past, we used a mechanical calculator. Now we design some logical gate for adding two numbers. But this logical gate and could only process with the input of 0 and 1, and 1 is for the power on and 0 for the power off. And with the two inputs, each input has two values, so we have totally 4 combinations. With 1, for example, 0, 0 becomes 0 with the carry in is 0, it becomes 0. And we can encode the binary operator by using, or we perform the binary operators by designing some circuit or gate to do automatically the calculations. It produces the output of an additional operator. That's this one. And this is called the half adder. The half adder just take only two inputs and produce two outputs So why it is called half adder? But for the full additional operator, we need 3 inputs like this one. One for the first is for A input, another is for B input, and the third one is the carrier values. So with the 2 input, we design the half adder like this one. It takes 2 input, just 0 and 1, and produce 2 outputs. And this is the design of a full adder. The full adder has 3 values: 0, the first, second, AB, and the carrier in. It produces only also 2 values of the sum result and the carrier out value like this one. And you could compare, the half adder. You could compare the half adder and the full adder in the same slide. You will see that the half adder has 2 logical gates XOR and AND, and the full adder requires 1, 2, 4, 5, 1, 2, 3, 4, 5 logical operators. More complicated and less emerging. This only the adder adding 2 numbers. Adding 2 numbers in binary numbering system. So just and one number would have, for example, in an integer using 4 bytes, we have 32 inputs for one number. So let's imagine how complicated the design of the automatic operator in our computer, just for integer number. And you could explore the design of our CPU, could explore the representation for the real number. You could explore how 2 numbers are multiplied by each other. For example, how float number are calculated using the logical guess. It's much more complicated, and different algorithms, different structure has been proposed to efficiently many design has been proposed to efficiently do the calculation in binary number. And now, supposing, I wanted to add 4 bits at the same time. So one way is that, in order to build a 4-bit adder, I just use a 1-bit full adder to do the calculation, for example. So in order to speed up the operation, speed up the add operators in our computer, I just use 4 1-bit full adder, like this one. Supposing that, I wanted to design a machine that perform adding 4 bits, 2 number of 4 bits at the same time. So I propose this one. Is that possible? Is that possible for this design to do the 4-bit number in parallel at the same time? Yes, so that's why, yeah, you know that it's difficult and it requires, yeah, it's difficult, and this is because you know that in order to add two number of 4 bits, for example, I take the first number, yeah, and the carry out, the first carry out is 0 to produce the S0. The second number into the bit, oh, the second number of the two, the second digit of two numbers, the third digit of two numbers, the first one, and I put all the two together at the same time to the 1-bit full adder. But the problem is that, yeah, we have to wait this full adder to finish the calculation, because the result of S1 depends not only on the input A1 and B1, but also the output of the first full bit, 1-bit full adder. And also, it means that with this design, we could not perform the calculation or put all the input bits together to the chip, to the logical gate to get the result. So that's not so easy. Design such machine is not so easy, but we know the principle. So up to now, do you have any question about about how binary numbers in system works in our computer? Okay, if you still don't have a question, I propose we have 5 minutes break. Now it's 3:09 according to my computer. So we will come back to our lecture at 3:15. 3:15 is.
Professor.
Thank you. Yeah, thank you very much. And yeah, please stand up and do some exercise. Yeah. Discussion point of this point for discussion question. Okay, yes. Thank you. This is a basic principle of working with number within with the number in different numbering system. And the main reason, as some people have say that, the reason why we use computer now are using 0 and 1 or binary numbering system, because we have now we limited in design the circuit and the machine that could work in with the 0 and 1 input signals only. So one homework for you, one problem, one question for you is that what is different between the normal computer, it means 0 and 1 computer, and the quantum computer, and why quantum computer is so fast when comparing with the normal computer, and why designing the quantum computer is now so difficult, much more difficult than designing the 0 and 1 computer. It's for your father for your further study. And I think that is very interesting if you you explore the differences between all the property of quantum computing. Yeah, once again, yeah, we have different type of data. People are trying to convert everything from our real life into the digital life. Currently, yeah, there are several types of basic information, including text, image. Image is that two-dimensional data, music, the time series signals, structured and unstructured data for video, for web pages, and everything. Yeah, are stored in our computer in 0 and 1. For most of us, for example, we use computer for our study, for our work. But for people working in the ICT field, for example, ICT students, yeah, we work in design or develop such kind of software. We develop tools, we develop software, we develop information system for manage people's information, or to process special type of information. And our main task and the task of informatics is that, yeah, it helps you to process your information during the your study here at USJS, as well as for your future career. So the informatics course help you to have basic knowledge and also basic skill in managing the information. Some theoretical aspect you will learn in the lectures here, like this one. You understand the fundamental knowledge, and in your practice hour, you will practice to process some popular type of information, including creating and processing the document, and do some basic calculation. For other advanced topic, you will learn in other courses, for example, for basic programming, and for ICT student, you will learn about how to process image, how to process, how to write or develop a software or a program to process the image, or how to process the textual data. It means that we study further in according to your field of study. And the logical file system usually, I said that usually, yeah, organizing in three structures. For example, in our computer, we would have one disk or server disk, or one disk divided into several partition. And in each disk driver, we have some different directories serving for different purposes, or different directory or folders storing different types of programs and informations. In each directory, we have subdirectories, and in the final lowest level, we have different data files like text file or image files. This is a common way of storing our information. And currently, we not only use our local disk driver, but we could use our disk driver in on the internet, for example, using cloud drivers. And we could also have the folder, the home folder, home directory in our servers. It will be provided by an account for using the computer system somewhere, for example, and you will practice to manage your informations in the practice hour. Yeah, for example, in the physical file system, you know that inside your computer, inside your mobile phone, you have the hard disk, or recently people use a solid state disk or another type of disk. And this, once again, you will see that the data stored in your hard disk or any devices have the raw data and the metadata containing the structure, organization of your data. So without your organization, without the structure of your data, you could not process the data in a correct way. And the homework for you is that, and is this also, explore by yourself about the data representation and file structures in your with your computer. For example, some of you have Windows operating system, some of you work on the Mac OS, try to figure out how to manage the informations with your computer, your own computer, and also supposing that you wanted to create a folder within your computer is rather easy. So how about do the same thing with your mobile phones? For example, how to do the for example access permission with your directory. For example, in this case, in Windows operating system, with the user in Windows operating system, supposing that two people use the same computer, and or you create another account, and you could not access to some folders. Another people could not access your folder. So that this is the user permission for accessing some specific location or specific folders in with your computer. So trying to do the same thing with your cloud driver. For example, trying to share your folders in your cloud driver with your friend with different type of permission. So in the future, surely I'm sure, surely you will experience that problem in the futures, because when you wanted to share the information with your friend. For example, in this case, currently I teach the computer vision course, and I share the all in the computer vision course. I share all the report of student in the last year, share for this year student, and people has the right to just to access to access that folder, but they could not modify or delete the content of that folder, because I just wanted to let my student to see what have been done in the last course. And one option for their final project is that they could develop when they could continue the work from other people is last year and improve the performance. For example, in that case, and lectures, we could you could share here in this case this computer vision course, and I asked the student do the project, write the report, upload the slide, and share the data for, in this case, for her project. And I share this folder I share this folder for the student in this year, in this computer vision, this year, lecture and projects. And one option for the student in my course is that to continue the project, of the previous year of the student in the last year. So I wanted the student to make the progress, to improve the performance, improve the result of previous people. Of course, this is one option. Another option is to work with or to build a new project. Depending on their interest. So I share this. I share this folder, but the share option here is just only for viewing, for viewing the folder only. New student could not delete, new student could not modify the content in that folder. For example, this very simple, that's a very usual activities or usual task in sharing your information with other people with different types of, for example, of permissions. So just practice, and to make sure that after you pass this informatics course, you use the computer, you use the computer system in a correct way. Please explore yourself about the world, the computer world, and do practice. And also in the future, please use the computer system in a correct way, in a safe way, and in an effective way, in order to have a better performance for your study and your performance on your future career. So I would like to finish our lecture today here. Please raise your hand if you have any question to our lectures. Please.
Professor,
yes,
I have a question about the midterm. So I have read the notification on the midterms that we will be tested on our Excels and Words. So what exactly is the format of the midterm? Do we need to like typing some kind of text, or is it multiple choice, or what?
This multi-choice test, including the practice and some theoretical question. For example, in theoretical question, we have the KISS test. It means that you multi-choice test, because it's will be conducted online this year.
The whole test is multiple choice, right?
Yes.
And the content is about Word and Excel, or is it about the whole 4 lectures?
Very basic knowledge about the informatics concerning the lectures. Very basic. I think that yes, including the practice, including the skill. There are two, mainly on the skill of making documents using word processor and calculation in the data sheet, for example, and theoretical question about informatics, including what is computers and main characteristic, main functionalities of operating system, something like that. And every content already in the slide. Please, I uploaded the slide on the Moodle, so if you follow the lectures, the question would be very not so difficult. So please do the practice, the theoretical question concerning about informatics is not so difficult for you, of course. Very basic question. For example, what is the main functionalities or main characteristics of an operating system, for example? Of course, I could show you some examples of the multi-choice test. Yeah, I will consider it. I will consider it in the next lecture. Next question, please. Hồ Quang Anh? No. Okay, if you don't have any questions, so we finish our lecture here today. And if you have any question, raise your question, send me the email or raise question on the Moodle or contact me. Yeah, of course, not so difficult. So you could discuss together or ask me in the next lecture. So thank you very much for your listening here today, and thank you very much for your contribution to the lecture. Actually, in the last year, because we do have on-site training and learning, some of you may have the bonus point for your contribution in our lectures. But this year we conduct the lecture online, so it's difficult to give you the bonus lecture in practice hour, but anyway, we are trying best to work with you to have the best result in our teaching and learning activities. So we try together to overcome the difficulties caused by the COVID-19 pandemic. So I wish you, or all of you, we have successfully passed the course and having the good result. And because this is the first year, and I wanted you have a good start, think up point, and good warming up for your second and for the third year. Because second and the third year we focus more on specialty of your research and your field. Thank you very much for your attention and contribution to my lecture. Thank you, and see you in the next lecture.
Thank you, Professor, and